We reviewed a lot of algebra today relating to parallel and perpendicular. So first, the equation of a line in slope-intercept form. We have the slope and the vertical intercept. The slope is how steep it is. We define that as rise and over run. So if you have 2 points, you can subtract the y's up in the skies, think y's in the skies, y's on top, and subtract the x's down below. So what's the equation of a line through these 2 points? First, find the slope. Subtract the y's in the skies, x's down below. Second, you need to find b. B is the vertical intercept. And how are we going to do that? We're going to rewrite y equals mx plus b, but now we know what the slope was from step 1. So y equals mx plus b. And then we're going to substitute any point that's on the line. Let's do 7 and 4. 7 is x, that goes right there. And 4, that's the y value. That goes right there. When we solve this equation, we know b, and there's the equation. We also in class did a quick example of going in the other direction. What if you have the equation and you want to plot this line? First step, plot the vertical intercept b1, which is where it crosses the y-axis. Second step, from that point, use the slope value to rise and run to a second point. And if the slope is -4, so you can think of that as -5 over 4 or 5 over -4. So we might rise +5 and run -4, or we might rise -5 and run +4. Doesn't matter, it's the same one line. Big idea in section 3.5, if the 2 lines are parallel, they have the same slope. If 2 lines are perpendicular, their slopes are both the opposite side and their reciprocals, which means we flip over the numerator and denominator. So some examples, if one slope is a perpendicular slope to another one, if one slope is 4/3, the perpendicular slope is the opposite reciprocal, -3/4. If the line slope is -5/9, the perpendicular slope is +9/5. If you have a whole number, you can think of that whole number as it divided by 1, so the perpendicular slope of 17 would be a -1/17. And for decimals, you can convert the decimal to a mixed number. 3.2 is 3 2/10. You could reduce that to 1/5, but I'm just leaving it, and then change that to an improper fraction. This is 32/10. That reduces to 16/5. So if the slope is 3.2, that's 16/5. The perpendicular slope will be a -5/16. And now for the most difficult question of the chapter. What is the distance from point D to line OG? This is our dog problem. Given that D's coordinates are -217 and O and G's coordinates are right there. Step 1. First thing you want to do is sketch it all. So D is there, O and G are there, and there's line OG. The distance from D to OG. Where would we represent in our picture the distance from D to OG? I hope you remember that would be the shortest distance from D to the orange line. That distance will be the shortest distance from D to the orange line. And the shortest distance will be represented by the perpendicular segment to the line. All right, we can answer this question then if we find the length of this blue segment. And this blue segment has to be perpendicular to the line. However, how do we find the distance from D to this blue point? How do we find the length of the segment? We need to use a distance formula, but we can't use a distance formula unless we know the point right here. We know that this one is -217. What is that point? So we have to find that point before we can use the distance formula that will give us the distance from D to the line. So we need to find xy for this point, and then that once we have those 2 points, we can use the distance formula, and that's how we'll do this problem. All right, we've sketched it. We understand that they're asking for the length of this blue segment, and in order to find this point so that we can finish the problem, we're going to have to do step 2. We need to find the equations of the orange line and the blue lines. we'll need the slope and the vertical intercept. The slope is the rise over the run, the ratio of rise to run. You can see to get from this point to this point, the vertical components are 0 and 7, so we'd have to rise 7 and then run however far this is. Well, from -6 to here is 6 units plus another 8 units, so that's 14. So we have to rise 7 and run 14. And as you read a book from left to right, this line is going up, so it's a positive rise of a run of 7/14. Now, if you actually use the formula and you subtract your y's in the skies, your y values are here in blue, 7 and 0. And your x values are here in green, 8 and -6. So this gives us a rise of 7 and a run of 14. So our slope is 1/2. We still need to know the vertical intercept. It appears to be approximately 3, but how can we be sure? We can take either one of these points. Let's take 8 and 7. When x is 8, y is 7. When x is 8, y is 7. When x is 8, y is 7. Now we can find b. 7 equals 1/2 of 8, which is 4 plus b, subtracting 4 from both sides. b is 3. So there's our orange equation. Now we need the blue line's equation. Let's do that over here. So let's start with the slope. Well, it's perpendicular to the orange line. So when the orange line's slope was 1/2, the perpendicular slope of our blue line will be the opposite reciprocal. So 2/1 and make it negative. So -2. And then we have to find that b value. So what point is on the blue line? This one. When x is -2, y is 17. When x is -2, y is 17. When x is -2, y is 17. So 17 is equal to 4 plus b. Subtracting 4 from both sides, we have that b is equal to 13. So if y equals mx plus b, our slope is -2, and our vertical intercept is 13. All right, we have the equation of our orange line, and we have the equation of the blue line. And to find the distance from D to the orange line, we need to know this point right here, this xy value, because once we know it, then we can use the distance formula to answer exactly what they're asking. So how do we find an xy value that's right where the blue line and the orange line cross? We're going to have to solve a system. Step 3. Our system of equations, where the equations are the orange line and the blue line. You see, when you find a solution to a system, in this case with x's and y's, you're finding the x value and the y value that make both equations true. If this is an x and y value that makes the orange equation true, then this is a point on the orange line. If it also makes the blue equation true, then it's a point on the blue line. If this is a point that's on both lines, then it's exactly where the lines cross each other. It's that point that we're looking for, that we need in order to find the distance from this point D to the orange line. All right, how do we solve a system? In the algebra review, which most of you didn't do, there were several systems to practice with the elimination method or the substitution method. In this example, we are going to use the substitution method. Step 1, get a letter all by itself. And it's already done for us. Y is all by itself. You could have let it be this Y or this Y, really anywhere in the system. If you can get a letter all by itself, you're done with that first step. Now that we have y by itself, we're going to take this expression that is equal to and substitute it into the other equation. Where does it go? Well, what is it equal to? It's equal to y, so it's going to go right there. We just rewrite the blue equation, but in place of y, we sub in 1/2 x plus 3 in its place. And now we'll solve this equation for x. We will add 2x to both sides so that there's no more x's on the right. So negative 2x plus 2x is 0. All that's left is 13. Do the same thing on the left side, plus 2x. Keep the scales balanced. 2x and a half of x is 2.5x. So we have 2.5x plus 3. Now we'll subtract 3 from both sides, so it'll be gone on the left. And here we have 10. And now we'll divide both sides by 2.5. X equals 4. All right, but we also need to know what y is, right? So we've got that taken care of. Now, what's the y equal to? All you need to do is come full circle to that first step where we circled that expression. It tells us exactly how to find y. You want to know what y is? Here you go. Y is 1/2 of x plus 3. And x is 4. So 1/2 of x plus 3 is half of 4, which is 2. 2 plus 3 is 5. So y is equal to 5. What have we just found after all this work? We have now found that x is 4 and y is 5. Oops. At this point right there. This point is 4, 5. Which means now we can find the distance, the one that they asked for, the distance from D to line OG. It'll be the distance from negative 217 to 4, 5. We have our distance formula between these 2 points. So the x's will get subtracted, negative 2 and 4. And the y's will get subtracted, 17 and 5. Remember, subtraction can always be changed to adding the opposite of the next number. So we have negative 4 and negative 2, which is negative 6. 17 minus 5 is 12. Negative 6 squared is a positive 36. 12 squared is 144. So we have the square root of 180. So in simple radical form, 180 is 36 times 5. Square root of 180 is the square root of 36 times the square root of 5. 6 root 5. Or if you use the factor tree, 180 is 9 times 20. 9 is 3 times 3. 20 is 4 times 5. And 4 is 2 times 2. So 180 is 3 times 3 times 2 times 2 times 5. So the square root of 180 is the square root of 3 times 3 times the square root of 2 times 2 times the square root of 5. And the square root of 3 squared is just 3, and the square root of 2 squared is just 2. 3 times 2 is 6. 6 root 5, we get the same answer. So, our answer, the distance that D is to line OG is exactly the square root of 180, which is exactly 6 root 5 in simple radical form, which is approximately 13.42. That's how far it is from D to the orange line.